Hi, everyone. My name is Samantha Wang, and I'm one of the product managers here at Influx Data. Today in my Influx Days talk, I'm going to talk to you about best practices on how to transform your data using Telegraph and Flux. So let's get started. So why do we transform data? Data is really transformed to make it better organized. Transformed data can be easier for both humans to read and computers to read. Data transformation facilitates compatibility between application systems and other types of data. Data can be used for multiple purposes and might need to be transformed in different ways. So your data for your query analysis might be different between just might be different from just being read by an application, and they might need to be in different formats and just needs to be transformed differently. A lot of problems that users encounter when they transform data, kind of the biggest one is that data transformation can be really resource intensive. Whether or not you're transforming on an on-premise warehouse after loading or transforming before feeding it into an application, data transformation can be incredibly huge on computational just burdens and slows down not only your transformation process, but a lot of other operations going on in your systems, in your architecture. Another problem you can run into is just with a lack of expertise and carelessness can introduce a lot of problems during data transformation. Data analysts without kind of the appropriate subject matter experts are more likely to introduce typos or incorrect data. For example, if you're working with medical data and if your data administrator, data analyst isn't familiar with that type of data, that can cause just a lot of typos or just kind of incorrect understanding of the data that you're going to be looking at and cause a lot of problems during the data transformation process. So those are definitely two things that you really want to be looking out for. While we have a lot of benefits of transforming data, there's a lot of problems that hopefully we can talk about and prevent in this talk. So some of the goals of today, we're going to hopefully look at how you specifically can transform your data to fit your optimal state of your monitoring environment. I think it's really important to make sure that we know that everyone's monitoring setup is different. Some of you guys will be working on really large enterprise scale environments. Other people will be looking on small OSS or even small cloud systems. But today I'm really hoping to teach you guys what Influx tool specifically can I use to transform my data, specifically for my use case. And the two main tools we'll be looking at will be understanding transformation of data before data ingestion using the power of Telegraph processors and aggregators, and the tools of transformation after data ingestion. So using the power of Flux transformation queries. So before we get started talking too deep about transformation, about these tools in general, I wanted to cover just kind of some basic concepts of InfluxDB. If you're already familiar with this, feel free to skip ahead or go get a cup of coffee or something. But I think that some of these concepts are really important in just understanding on how to transform your data with InfluxDB specifically. So this is just a really, really basic look at what your just not even InfluxDB, but what your database will look like. So on the left, we have whatever you're monitoring or whatever you're collecting data, your devices, your servers, that type of data you'll be ingesting into your database. So you'll be taking that, bringing it into your data, ingesting your data and bringing it into your database, and then kind of that data just sitting there isn't that useful. So you want to do some query analysis to visualize, do forecasting, machine learning, or looking back on analytics and being able to take that raw data and doing something and get information out of it. And here in most databases, we have 2 points of transformation. Kind of your ETL versus ELT, kind of your extract, transformation, and load. I'm not going to use these terms too much in this talk. This is probably the only time I'm going to bring it up, because I think I'm going to try to emphasize that you don't really necessarily have to have one method or other. I guess these tools will be catering towards one method or other. But for example, if you're going to be doing it and before you hit your database, kind of your ETL model versus after, to help transform data for your visualization analytics. Those are the 2 kind of points we're going to talk about today. And I just kind of wanted to kind of a good understanding of why, once again, we want to make sure we transform our data. And we can think, I've personally been doing a lot of cleaning, organizing in this quarantine. It's kind of taking like a bunch of stuff that you have, groceries, linen, your linen closet, kind of just everything is a mess. How can we get it into a state of, I can go back to this and get use of it, instead of kind of maneuvering through all this mess? How can I, what stuff do I need to throw away? What stuff do I need to, how can I group things here and there? How can I add some human readable labels? How can I make things more kind of visually appealing to the eye? So every time I return back to it, I'll be able to easily just kind of go back, get what I want, get the information I need out. And I think that's kind of just a good description of getting from kind of the left of what you're collecting to the right of being able to get good, useful information out of it, out of your data efficiently. So translating that into how does this relate into InfluxDB? This is kind of what your architecture will look like with your InfluxDB. Once again, we have on the left side the thing that you're monitoring. Here we have Kubernetes, networking, Prometheus, kind of your databases. Feeding into Telegraph, that's the data ingestion point where you can be doing your transformations, and then feeding that into your database, your InfluxDB database. And here we'll actually, with our InfluxDB2 model, your database, your querying and visualization is done in InfluxDB itself. And we'll be talking today specifically about Flux, about how Flux can enhance your visualization and querying for your data. So I wanted to make sure I just covered InfluxDB Lime protocol. If you're completely new to InfluxDB, this is a really important concept in understanding how your data is stored, and I think is really important in understanding a lot of the transformation we'll be talking about in the upcoming slides. So InfluxDB Lime protocol is kind of how your data is stored, and it consists of 4 different things that we're going to cover. So first off, your measurement value. So your measurement is essentially the description of what you're measuring. You're measuring, it acts as the container for the tags, the fields, and the timestamps that you're collecting. So in this case, what I'm measuring is weather. This is an example directly from our documentation, and I'm going to be kind of just measuring weather data. And your measurement value will always be a string. Next, we have tags. So tags include tag keys and tag values. So in this example, your tag key is your location, so essentially the name of what your tag is, and then your tag value is that actual metadata. So here would be US Midwest. Another line point might be US West. Could be even be this is North America influx stage. Could be Argentina. Could be Argentina or Brazil. Kind of wherever your location is. And so your tags are stored as strings, and this is essentially kind of the metadata of your data points that you'll be measuring. And I guess to mention, you can have multiple tags as well. But next, kind of the actual concrete of the juice of what your data is consistent of are fields. So fields are like tags have a field key and a field value. Your field key is the name of your field. So this example, temperature and humidity, and your field value is that associated, the value to that associated field key. So here, your field value for temperature would be 82 degrees. And your field value for humidity would be 71. It's important to note field values, that's being kind of the data where you're measuring, can be strings, floats, integers, booleans, kind of your typical data types. Lastly, kind of most importantly, kind of just in this whole InfluxDB concepts, we have our timestamps. As InfluxDB is a time series database, we got to make sure we have that timestamp. All of our data in InfluxDB is stored with a time column on it, on disk, kind of shown here. Your timestamp will be stored as in your epoch nanosecond format when it is in. So kind of just every single one of your series, kind of every measurement, all your data points will have an associated timestamp. So this is a really important, just key InfluxDB concepts that kind of just make sure you're familiar with while you're using InfluxDB. Okay, so now we're going to kind of go into understanding how we can utilize our tools. So first off, we're going to talk about how you can transform your data before loading into your database and transforming this data with Telegraph. If you guys aren't too familiar with Telegraph, this is a really good, I think, high-level understanding of what Telegraph is. Telegraph is our plugin-based agent. So we have kind of made up consistently of input and output plugins. Your input plugin would be, once again, looking at whatever that stuff was on the left, what we're going to be monitoring, those databases, those networking devices. Your input plugin, you'll have an input plugin designated to what you're going to be collecting. So maybe your Docker input plugin, your MySQL input plugin, CloudWatch. We have literally hundreds of I think kind of at this time, at the time of recording, at least 180 input plugins, consistently growing, especially with our kind of external plugins that we're having as well. And then on the other end, where your data is going to be routed to, we have our output plugins. So, and to make sure it's important to know that you can have multiple inputs and output plugins. So you can be monitoring different types of things with one Telegraph, routing it to different places, routing it to InfluxDB, as well as a file, also InfluxDB, and CloudWatch. You have a lot of flexibility with Telegraph. But what we're really going to focus on today is really this kind of centerpiece of the center area of Telegraph with these processors and aggregators. Since we're talking about transforming your data, the processor and aggregators are really what allows you to decorate, filter your data, do kind of basic mathematical functions on your data, aggregate, merge, clone your data. Stuff we'll go over, but it's really important to know that this can all be done within Telegraph using these different types of plugins. So I'm going to touch base a little on why you shouldn't be manipulating your data with Telegraph. I'll talk a little bit about this more on how it might compare to Flux, but just covering why should you manipulate your data or transform your data with Telegraph. One of the big things, talking again back to our InfluxDB Lime protocol, converting your tags and fields or other data types is a really common use case, and being done with our Telegraph processors. Renaming field names or field values, aggregating data, kind of making it simpler, cleaning up or filtering data. This is a pretty big one as well. Just making sure that you use Telegraph as a method to, once again, talking about all that kind of junk. Not saying your data is junk, but having that messy data, cleaning it up, getting rid of stuff that you don't care about, even though your device is sending it out before it hits your database, so it doesn't overload your database, and just kind of gives you a cleaner setup when you're doing stuff with your database. Performing data transformation as close to the device as possible. This is a common request that we get, that people want to use. People want to get enhancements to Telegraph itself because they want to do stuff as close to the device as possible. And lastly, kind of that problem I mentioned, improving performance by doing your data transformation and manipulation in Telegraph. So I'm just going to walk through a few examples of ways you can transform your data with Telegraph, kind of the first one being converting your data. One of kind of our most common use cases when your data, when you have your data that you're ingesting and you need to convert it. And this can be done with our processors converter, one of our most common processors and just plugins in general. One of the main reasons for transforming your data prior, or I guess during ingestion, is that you can often be reading your data from your servers incorrectly, or it's just coming in not necessarily the way that you want. So in doing so, if we look at just kind of this converter processor, all of our Telegraph plugins are configuration based, and we do this to try to make this kind of really as simple as possible for our users. And here you can just see it. This is TOML, pretty straightforward. I like to say it's like a form that you're going to fill out in your configuration file of changing X to a tag, changing a tag to a field integer, all kind of, you can see kind of pretty simply in this sample configuration over here. But say you want to convert tags and fields. It's a common problem that people run into, and is really important for our InfluxDB formatting, is making sure that you get your tags and fields correct. Kind of a common example of that problem that comes up is when you're monitoring your Kubernetes, that input plugins can create just a lot of tags depending on the use case. And if you, and we've had this problem come up that pod names will be different every time the pod gets redeployed. And it kind of requires the data administrator to have to decide whether or not this tag really should be a tag. Should this actually be a field? I think just this problem that people have been encountering, it's like you're coming in with 20 tags when 18 of these tags should actually be fields. And so this is something that a lot of our users need to do, and can be using the converter processor. So for this example, we have our converter processor converting our existing tag named port. Here you can see we have port 80. It's here in our line protocol listed as tag. Putting it in our converter.tags as a string, we're going to convert it into a string field. So here you can see it moved from port 80 as a tag to a port 80 as a string. Say you wanted to kind of go the other way around, switch a field back to a tag, or just a field to a tag in the first place. You can do that really simply as well using the converter.field. So designating that your whatever field that you have, listing in this case port, putting it in that tag, that tag configuration. Here we have our port, that's a string, moving that back into our tag. So pretty straightforward, just really easy to configure, converting back and forth between tags and fields. So another really common just data transformation that people need to do in general is converting data types. Here we're going to look at how to convert kind of a field pattern that you might have, and converting all. So in this case, we have your scoreboard, SC board, underscore. We want to convert all of those fields to an integer. So this is really easy with the converter tag as well. If you only need to do one field specifically, you could just list out the field. But in this case, we want to do everything that has kind of SC board underscore and whatever that field pattern is. So looking at our data that we're getting in, we have SC board underscore open, reading, sending, starting, waiting. We want to convert all of those with that field pattern to an integer. So using this processor, relatively. Adding this into your configuration file, we see we have everything, all of our SD boards, fields, all converted into integers. So mapping is also a very common data transformation technique that people end up wanting to use. And with Telegraph, you would be using our enum processor. Our enum processor is really helpful in value mapping kind of metric tags or fields. The most common use case we really see for this is mapping status codes. So for example, if you want to assign red, yellow, green, kind of these critical warning good fields to numeric values of 0, 1, 2, or maybe vice versa, that's something that you can do with Telegraph and the enum processor. The example we have here, we have our list of our device only, this is an SNMP example, only emits object identifiers for SNMP, and we have that coming in as a tag as our storage type, but we want to add another tag and put it as our destination name, with kind of, once again, talking about why we transform data, that human readable kind of storage location. So with our enum processor and our value mappings, we can designate what object ID correlates to what storage name, and we can map that really easily with this processor. So in our example, we have our storage type ending in .2.1.6, and based off of our mapping, that should be our great old floppy disk from 1998. And so when you add this processor and output it, you would be able to maintain your tag, your existing storage type tag, and add another tag named storage name, and you would get floppy disk in your tag. If an unknown value is passed, so for example, if kind of based off here, we don't have 2.1.9 set, so if that was passed through, no default would be set, but your value wouldn't be dropped. It just wouldn't have a storage name tag to it. All right, so transforming actual kind of values of your tags in your fields. How can I do that? This is a common thing that people have requested as well. So with Telegraph, you would be using what we call our regex processor, and would utilizes regex patterns on doing these transformations. So you can change tags or manipulate fields with regex patterns. You can replace existing fields or even just produce new ones. So if you wanted to just kind of transform your actual field value and completely get rid of it, that's something that you can do, or add another field while maintaining the existing one. So this is an example that we have. We're going to change the data in the value of our tags and their fields. And here we have kind of just looking at the way this is configured. The key is what we're going to be transforming. We have our regex.tags that we're going to be transforming the actual value of our tags, but not being replacing it. So here you can see in our field transformations, we have stuff called result key, a result key field that we'll have to configure. So when we have a result key, it will produce new fields, in this case new fields, also new fields and tags, while maintaining the existing ones. While when we don't have it, it will just completely replace our tag or field that we're using. So looking at our sample data, we have a response code 200, and we want to transform that to be whatever number it is, .xx. We're going to be adding some additional fields. So we can see with our naming our result key, we're going to add a field called method and a field called search category. based off of our request fields. So looking at this configuration specifically on this sample data, this is the output we would get. So we would have our original response code of 200 that would change to 2XX based off of our regex pattern that we're setting. Our request field will be, we're going to be taking the information from a request field, adding our method so we can see that we're pulling that kind of search, whatever ends up in that part of our request field, and then also adding a search category. So in this case, our category that we were able to pull was plugin. So whatever ends up in, whatever is being transmitted in that request field consistently, we're going to add another field called search category and pull that data in. And everything, all your other fields will maintain the same. We're not touching your refer or client IP fields. That will all remain the same. But yeah, here we can see how you can transform your values and replace them, or also just add another field as well. So this is actually something that we added pretty recently, math and logic operations. Our head of applications, Barbara, actually talked about this at our Influx Days London, using something called Starlark, our Starlark processor. If you're not too familiar with Starlark, Starlark is a dialect of Python. If you want to learn more about Starlark, feel free to go to the Starlark specification. It has a lot more details about the syntax and available functions. We found it most familiar to use cases for Starlarks for math operations, logic operations, and some string operations. It's important to note, looking back at that syntax, adding or removing fields and tags is important as well. So here's an example of just doing basic math with Starlark. The example I have is using kind of your Modbus plugin, calculating, for example, if your Modbus plugin outputs your current voltage but doesn't have power, and that's something that you want to calculate with Telegraph, that's something that you can do with Starlark. Just pulling in those fields and calculating and return another metric that we're here naming power. It's important to know, I think, you would feed into your Starlark script. You can only have really one Starlark script or source per processor. So if you wanted to add more math functions, you would just need a Starlark script for each one. There's definitely a lot of, I think, just different blogs. There's a demo video on our YouTube page talking more about Starlark. Definitely go in and play around with it. This gives you a lot of flexibility. I think us ourselves haven't even probably discovered, but we have some examples in our GitHub, in the GitHub README of doing number logic. We just added kind of JSON capabilities, renaming capabilities. Just there's a lot of flexibility and hopefully different things that we'll all be able to discover to use Starlark. But yeah, so this example, we had our current of 550 and our voltage of 12.9, and we multiply this together and we'll get another added field of power. So I'm not going to go too deep into these other ones, but I just wanted to kind of, the stuff I've touched about is really just I guess essentially three of our processors that we have. We have so many more of ways you can transform your data. I think kind of really important ones are kind of like dedupe. Our dedupe processor is filtering out exact repetitions of values, parsers, different processors, so being able to parse different data formats. That is a processor and a type of data transformation. Some ones that we have been adding have been kind of really plugin technology specific. For example, this ifname processor we had looks up network interface names using SNMP. So we have added a few of those, just kind of lookup type plugins that can be particularly useful depending on what type of technology you're using or what you're monitoring. But yeah, definitely just check out our other list of really powerful and useful transformations. And I didn't touch too much on aggregators as well, but these are things that you might be using as well. Min, max, kind of pulling especially with time series data, pulling the min and max values of that is being read in, merging data together, just a lot of different types of aggregators that you might have. Okay, so now kind of moving on to after loading, transforming your data kind of after it's in the database with Flux. So once again, if you're kind of new to Influx, why Flux? What is Flux? I won't spend too much time here. I think we have a lot of information, a lot of great content on why you should be using Flux, what are really just the big benefits of using Flux. But Flux is Influx Data's functional data scripting language used for querying, analyzing, and just acting on data in general. And we introduced Flux because it really gives you a lot of capabilities that you wouldn't be able to get with in our existing querying language of InfluxQL or even SQL. Our Flux team is constantly building enhancements for Flux, and I think one of the beauties of Flux is, once again, knowing it's really built for acting on time series data. So if you're looking for a really efficient kind of way to query your time series data, Flux is it. It's really easy to use. In the kind of as low of a programmer as you can, or coder as you can get, and I can even do Flux. So we're going to talk a little about a few capabilities and functions, Flux functions that you can do. Once again, go to our docs and look at the whole scheme of things and how to get started with not only transforming data with Flux, but Flux in general. So I just kind of everything we'll be talking over the next few slides is all important to know about the map function. So our map function, 99% of our data transformations can be done with the map function. The map operates one row at a time. And it's really important to note that it won't remap without the with statement. So without that second with statement, you'll perform whatever function you have in your function and would replace it unless you have that with statement in your function. So with our with statement, we would take whatever our value column is, multiply it by 2, and add a new column. In this case, kind of name new column, whatever you decide to name it, and you would remap that to our value to this new column. Things that you can do with map: basic mathematical operations, conditional logic that we'll both cover today. But I think just adding new columns and tables is really powerful, and kind of that data transformation that you can do with map. So mathematical operations, kind of just really what you are really wanting to be doing with the querying and language, or doing data analytics. This can all be brought in using what we call our Flux math package. So you would take that import math file. I guess I wanted to touch base that if you haven't seen, I've even kind of just spurred a lot of ideas from our Influx Days London 2020, Scott Anderson's talk. He talks solely on using the map and reduce functions, and he'll go into a little more detail on on understanding your syntax of math and kind of more of the details of math in general. But and we'll talk about math and string and other things that I am too, just in a little more detail as well. But our math operator provides our math Flux package provides a handful of capabilities. So we have constants. For example, here we have kind of pi constants, kind of just your basic math that you want to be doing, adding two values, dividing, kind of just that analytics you want to be doing, rounding capabilities, floor, ceilings, and all those kind of powerful math capabilities can be done in conjunction with our math Flux package being utilized within map. So string manipulation and data shaping is something that you can also do with Flux. This is actually kind of one of the beauties of Flux, it being a data scripting language. InfluxQL actually did not support string manipulation. This is something that we were able to add with the development of Flux. So we have, like our math package, we have a string package that is a collection of functions that allows you to operate on string data. So when combined with the map function, the string package allows you to just do a bunch of operations of sanitation and normalization on your strings. My examples here, this is the fall of 2020. This has been my song of the summer, was really just getting me through this quarantine, was Lady Gaga's Rain on Me. So I wanted to use some of these great lyrics as examples for how you can use our Flux string package. So you have kind of really the basic, or kind of the things that you expect to do with string manipulation. So you have your concatenation. If you had a column rain on me, rain, another column rain, merging, joining them together with our string package, you can get rain on me, rain, rain. Splitting text out, you have a whole column, splitting a whole column into individual column rain, another column on, another column with me. Substring, being able, the process of extracting a portion of your string. The way that Flux does it is by designating the start and end value. So say we had just we had a list of names and we only wanted to extract Gaga. That would be started at 5 and ended at 8, and you would have another column that would give you the name Gaga. Case conversion, something that the Flux package can do under Case Chromatica, gives you to uppercase Chromatica. Searching is also, I think, a big common one as well. Being able to note, if I really want to know if my data set comes with Lady Gaga lyrics, and wanting to know if down is included in there, being able to report that back as true, or if there's a subset of a string that I want to see if my data is included in there. Lady Gaga lyrics probably won't come up in your time series data, but never know. So conditional logic, like in Telegraph, is a big use case in that people want to do on that query side as well. It's a really common use case, and this can be once again done with our best friend Map, like Dora. But if you want to do kind of these if then else statements, this is something that you can do in Flux as well. The example I have here at the time of recording, or actually even the time of that I was building this presentation, start of the MLB playoffs had just begun. I had MLB data sitting in my InfluxDB cloud, and kind of an easy example, we've been able to kind of, let's see what teams, let's add another column of what teams made the playoffs and what teams didn't. The MLB data set I have kind of already did some filtering and manipulation to it. Just looked at AL teams. With the AL teams, we could look purely at wins to build a simple conditional logic. And based off of our conditional statement before, essentially all teams that with 29 or more wins made the playoffs through the wild card or winning the division. So we want to designate another column called postseason, add playoffs to it, maybe adding they were so close, and then kind of those teams that didn't fare so great, adding a better luck next year value in that postseason column. So with our original table, adding this conditional statement, we can map kind of whether or not these teams made the playoffs or not. So no, I guess once again, not necessarily the best time series example, but can really just show you how these kind of data transformation techniques that you expect just in any database or language you can do with Flux. So you might be asking, kind of, Telegraph and Flux both sound great. What should I kind of what should I do now? Like, how do I apply this to my InfluxDB, or how can I best utilize it in my InfluxDB database? And so when should you be doing something in Telegraph or Flux? I wouldn't necessarily recommend there's kind of one better way or the other. But I think it all really, once again, our use cases are different. Are you really concerned with kind of your system being too resource intensive? Do you want to do a lot of your data transformation before loading? Then you would use Telegraph. Do you want a little more flexibility in your querying or data analysts? Then you should be using Flux. But kind of the basics of why you should be doing data transformation with Telegraph, bringing it back to that importance of that LIME protocol, data and tag manipulation for data routing. A lot of data kind of filtering out that data before it reaches InfluxDB are done with tags filtering for data routing. So making sure that your tags and fields are in the exact state that you need to do, and so you can get that set and kind of not have to touch it again. That's something that you should do and have cleaned up in Telegraph. Just cleaning up data in general, I think that's really key to do with Telegraph. So what do you want your data to look like when it's in InfluxDB? Getting that done in Telegraph, so you can just, every time you go back to your InfluxDB, your data set, when you're going into your data export in Flux Cloud, having that clean data and having the names look like what you want to be, having the data types in what you want to be, doing that in Telegraph can really ease up the workload later. Permanent transformations to improve performance, to improve performance on the query side. I think the emphasis on permanent transformations is important. I think could just really help ease up any problems you might encounter later. We occasionally get some users talk about, oh crap, I did this with Telegraph. How can I fix this mistake I already did? And it's definitely possible. Kind of everything is possible with InfluxDB, but just doing as much as you can that you want done permanently with Telegraph can really help that resource intensive problem that we had talked about in the beginning. And I think is a solution that a lot of people are looking for when transforming their data. So how about Flux? I personally think kind of how should you approach data transformation with Flux? Using Flux to get your data in the state that you want for query analysis, or just even visualization, having your table look like what you want, for example, that conditional logic that you want. So being able to come back to it and being able to get that really organized data to be able to take action on is how you should use Flux transformations. Getting data into your state to do your querying or your visualization, kind of thinking back to that organization, going into opening your pantry or refrigerator and seeing it the way that you want, so you can go in and do what you need to easily and be able to act quickly on that kind of labeled data, or that color-coded data is stuff that you can do in Flux. Talking about that mapping, being able to create new columns and tables, and I'm going to tie this into the last bullet point, just flexibility as well. If you want to add a column for this analysis you want to do, you want to do that in Flux. You might not use it every single time. You've been tasked by something from your boss, just adding tables or column or fields to be able to do for the data analysis. And I think most importantly, kind of the opposite of the last Telegraph quote is the flexibility. Flux gives you that flexibility to transform your data and then being able to go back to it and always maintaining its original state, or going back to its original state. I think that's one of the big benefits of Flux. So yeah, definitely just kind of play around, find what that nice balance is for you and in your monitoring environment. Is really I think the suggestion I can give. But thank you very much for watching my talk today. I mentioned the documentation a lot, our GitHub readmes. Please go in, look at our whole list of Telegraph processors, go in, look at our Flux documentation, how to get started, all kind of the functions and capabilities of Flux, and kind of go from there. Hopefully you enjoyed the rest of your Influx days and just using InfluxDB in general.